Good morning. Myself Dr. P.R. Krishnaveni, Associate Professor of Chemistry, Sasi Institute of Technology and Engineering, Tadapalligudem. Welcome to the lecture on thermal analysis techniques. In earlier session, we had discussed about carbon nanotubes. There we have discussed what is meant by carbon nanotube. That means carbon nanotubes are nothing but the allotropes of carbon. Belong to fullerene family. And they are formed from graphene sheet. Next we have discussed about the types. In types we had discussed the classified carbon nanotubes as single walled carbon nanotubes and multi-walled carbon nanotubes. Single walled carbon nanotubes means they consist of single roll of carbon. That means graphene sheet. In multi-walled carbon nanotubes they contain two or more carbon sheets. That means the graphene sheet will be rolled like a newspaper, so the two or more layers will be formed. Again, coming to the classification of single walled nanotubes, they are classified into three types basing on the indices N and M. These are nothing but the unit vectors along the directions of the honeycomb crystal lattice of graphene. So when M is equal to 0, they are called as zigzag. If N is equal to M, armchair. When N not equal to M, chiral. Later we have discussed about the preparation methods of carbon nanotubes. In preparation methods we have discussed three methods: arc discharge method, laser ablation method, chemical vapor deposition method. Next we have discussed about the properties of carbon nanotubes. Coming to the properties, we had discussed the mechanical properties. That means tensile strength, hardness and elasticity. Electrical properties. Carbon nanomaterials will show conductivity from semiconductivity to superconductivity depending on the diameter and chirality of the molecule. And the next property is catalytic property. Y means nanomaterials will act as good catalyst, especially made of transition metal oxides. And further catalysis can be enhanced by using platinum or gold. Next, vibrational properties. Y means the carbon atoms in the carbon nanotubes can move to and fro. As a result, they will exhibit two modes of vibrations, A1G and T2G. Later, we had discussed the applications. Coming to the applications, carbon nanotubes finds application in drug delivery, provide oxygen, they help in killing cancer cells, they are used in aerospace, that means in making aircraft components, high energy density batteries, and high definition television. So these are the topics which we had discussed in our earlier session. Now coming to this session, I am going to discuss about thermal analysis techniques. So thermal analysis means it's a general term which is used for defining or which is used to analyze the thermal analysis is a general term defining a technique used to analyze the time, temperature at which the physical changes will occur when a substance is heated or cooled. So each technique is defined according to the type of the physical changes being analyzed. Measurements are usually made with increase in temperature, but isothermal measurements or measurements with decreasing temperature are also possible. Physical properties include mass, temperature, enthalpy, dimension, dynamic characteristics and others depending on physical properties are to be measured using thermal analysis technique. So the common thermal analysis methods and properties that are measured are differential thermal analysis. So the abbreviation is DTA and here the property measured will be difference in temperature. And differential scanning colorimetry, abbreviation is DSC and here the property measured is enthalpy. Next one is thermogravimetry analysis, abbreviation is TGA and the property measured is mass. Next, dynamic mechanical analysis, abbreviation is DMA and property measured is deformation. Next, dielectric thermal analysis, abbreviation is DEA and the property measured here also is deformation. Next, evolved gas analysis, abbreviation is EGA and the property measured is gaseous decomposition. And next one is thermo-optical analysis, abbreviation is TOA and the property measured is optical properties. So this is how the physical changes or chemical changes taking place due to change in temperature. So here the physical change is taking place. Here also physical change, here chemical change is taking place, here physical change is taking place, here also physical change. So what happens when a matter is heated? So when matter is heated, it undergoes physical changes and chemical changes. Here physical changes means they undergo phase change. Phase change means they will undergo crystallization, melting, vaporization, transition between crystal structures, or change in microstructure of metal alloys or polymers. Chemical changes. Chemical changes means they will undergo reactions to form new products. Here, the reactions that can take place are oxidation, reduction, decomposition, dehydration, etc. The most commonly used techniques in pharmacy are thermomicroscopy, differential thermal analysis, differential scanning colorimetry, thermogravimetry. Now coming to thermogravimetry analysis. The basic principle of thermogravimetry analysis is that mass of a sample in a controlled atmosphere is recorded continuously as a function of temperature or time. As the temperature of the sample is increased, that usually linear with time. So here what they will be measuring means measurement of change in mass with respect to temperature. Here temperature, it will be increased at constant rate on known weight of sample. And measures the change in weight. Here actually we will be measuring the change in mass. What is the difference between mass and weight means? Mass is nothing but the amount of matter in the sample. Weight, weight refers to the effect of gravitational force on mass. Mass is the amount of matter in the sample and weight is the effect of gravitational force on mass. So by observing this, we will be getting the thermogravimetry analysis report in the form of a thermogram. A thermogram is nothing but a plot of mass percentage with time. Next, coming to the instrumentation. The basic components of thermogravimetry analyzer. A thermogravimetry analyzer means nothing but thermobalance. The components are balance, furnace, sample holder, temperature measurement, computer data acquisition, processing and control system. This balance and furnace, these two are the key components key components of Thermo balance. So in general, the Thermo balance usually works in the range of 1 milligram to 1000 milligrams with the usual sample range from 5 to 20 milligrams. So this is the picture of Thermo balance. So coming to the balance. Here what this Thermo balance will be doing means this will provide electronic information of change in mass. That is the reason why we are saying balance as one of the key component of Thermo balance. Here two types of balances can be used. One is null point type balance and the other one is deflection type balance. So in null point type balance, here the balance beam will be capable of moving away from the normal position when the change in mass of the sample takes place. Here we will be keeping the sample. Now coming to the furnace. So this is the furnace. Furnace usually operates in the range of ambient temperature to 1000 degrees centigrade. Although there are some furnaces which will act up to 1600 degrees centigrade. And this furnace should be insulated and it should be cooled exteriorly. Otherwise what happens means the temperature or the heat will be transferred to the balance. And not only that, this furnace is usually perched with nitrogen or argon in order to prevent the oxidation of the sample. Next one is sample holder. The sample is usually placed in sample pan. Sample pan is nothing but they will be placing in crucible. These sample pans are usually made with platinum or aluminum, and most of the sample holders or the crucibles will be made with platinum. Why means because of its inertness and ease of cleaning. Commonly platinum is used. Next one is temperature measurement. Temperature measurement can be done using thermocouple or by using resistance thermometers. In thermocouple, vials are usually made with platinum, nickel, rhodium and chromium, and the electrical resistance of the metallic conductors can be increased with increase in temperature. Next one is the data processing system, recording and data acquisition. So here the data will be obtaining in the form of thermogram. That means which is nothing but a plot of mass percent as a function of time. In the next session, I will show you some of the thermograms obtained from thermogrammetry analysis, and we will discuss the advantages and limitations of thermogrammetry analysis. Thank you.